Hello YouTube. For this video we are going to look into branching, which is also known as like if, else if statements, also else statements. And it's the first time in our code where we're going to see that instead of every single line in our code executing, there's going to be a choice made in the code to take a certain decision based on variable values or some other condition. So this is the first time your code won't run the exact same thing every single time. Okay, so let's get started. So this is commonly referred to as branching. So that's what I'll go ahead and name the file. It includes if, else if statements, switch statements, different stuff like that. But today we're going to focus on if, else if, and if else statements. So we'll call it branching.cpp. As always, let's go ahead and throw in the IO stream namespace std in main. Okay, so now we got our basic shell set up. So for this video, what I'm going to do is I'm going to do a number guessing game in order to illustrate the different branching statements we can use. So I'll make a couple integer variables. So first we'll call correct num, and that's the value that we want the user to guess. And let's set it to 35. Can set it to anything, and the reason you make this a variable is that you can change it at any time if you want to update the guess. And you could even do something where you have a user first enter a number and then pass it to a second user, so that way they first enter the correct num and then have the second one guess. But for this, we're just going to go ahead and set it to a default of 35. And then also we're going to create another one called guess. Just to be safe, we'll initialize it to 0. And so that will work for our basic output. And then so we're going to do enter your guess. So right now we're just going to prompt the user for their input or their guess for our number. Guess. And then, okay, so now we're getting the user's input for guess, and now we're going to use that with branching. So the first statement we're going to look at is if. So it's formatted in the following way. So kind of like how functions are, you encapsulate everything within the statement with these brackets. And there's these open and closed parentheses, and they're not like the top part up here for main, where it's like arguments that are passed in. What this does is it checks whether whatever's inside here is true or false. So if we had a Boolean and it was set to true, then whatever's inside this bracket will be executed. And if it's false, then it'll basically essentially skip over this part and continue on. And so the first operator that we're going to use is equal, and this is how you check if two numbers are equal to one another. And one thing to keep in mind is it looks a little weird. Let me just show it first. So correct num equals guess. So you may wonder why there's two equal signs, and the whole reason this occurs is because the one equal sign is already dedicated for when you're like assigning a variable. So when we say correct num equals 35, it's called variable assignment, and it's already reserved for that. So equals is the way they kind of did a workaround in C++, and that compares two values. So what this will do is it says if correct num is equal to the guess, so in this case, if whatever the user enters is equal to 35, then whatever is inside this block of the if will execute. So we'll have it do something like you guessed correctly. Give them an exclamation mark, do the end line. Okay, so now just to reiterate, it'll check if the user enters 35, and if so, it'll say you guessed correctly. Otherwise, this if statement will be skipped over and nothing will happen. Let's go ahead and show that. So let's go ahead and compile it. And so let's start by guessing correctly. So 35. There we go, you guessed correctly. But now let's run this again and then see what happens if we guess something incorrect. So let's try a number like 21. As you see, nothing prints to the screen. So that whole little part inside the if statement was skipped. And that's something different in our other codes, whereas no parts of the code are skipped. But branching allows you to do that, to kind of have the code make a choice of what to do next. And then just to show that it wasn't a random happening, let's go ahead and choose a number that's above it, like 55. And again, nothing happens. Okay, so now let's go ahead and expand on that, because just saying whether you guessed correctly or not doing anything is not the best way to do it. So along with ifs, there's also something called else. So let's go ahead and show that. So else is a little bit different in this format, and you'll notice it doesn't have parentheses after it. And that's because what an if-else like conjunction does is if this evaluates to true, this code will execute. So cout will execute. Otherwise, or else, this will execute. So if, in this case, if the user enters anything besides 35, whatever is in this else block will execute. It's kind of like the default catch-all. So if it wasn't already true with another if statement, then with the if statement, then it will evaluate into the else and then execute whatever's inside that code. So see this in action. What do you guessed wrong? And now let's see how this works out. So let's go ahead and compile again, run our a.out. So just to make sure nothing changed with guessing correctly, we'll go ahead and run that. So the if statement won't be changed. But now, let's go ahead and run it again. What happens if we enter like 21? Now instead of just skipping and doing nothing, it says you guessed wrong. And we can do this again with a larger number, 55, and then same thing. So if we enter anything besides 35, it'll say that you guessed wrong. And so this obviously adds functionality to the program and makes it better. But we can do even a little bit better and give the user a little more to work with. So then what we're going to do is use what's called else if. So for a second, I'm going to go ahead and delete these lines. Just so you know, in Vim, Shift D will delete lines. And it's the quick way to do it. And then I to reinsert. So now the other part that goes with if is called else if. And this is different than else in the sense that you will have the open parentheses again. And this just shows, or how you can read this is, if this is true, run this. Otherwise, if this is true, run this. And you can have as many else ifs. You can only have one if and one else in the same like block. But you can have as many else ifs connected as you need. And so let's go ahead and do something like this. So if guess is less than correct num, which means the user entered a guess that was lower than what we wanted, we're going to say whoops, your guess is too low. And then let's go ahead and add in another else if for the opposite condition. So if guess is greater than correct num, we're going to do cout your guess is too high. Okay, so we should have covered every case, because if it's equal, so basically what this says, as you can read it through, is if the guess is equal to correct num, you say it guessed correctly. Else, if the guess is less than the correct number, your guess is too low. Then lastly, if the guess is greater than the correct number, your guess is too high. So let's run it, make sure it works as expected. Compile. Okay. So let's, as always, start with 35. You guessed correctly. Nothing changed there. But now if we enter 21, whoops, I have to run that again. Now if we enter 21, you're going to see your guess is too low. Let's run the executable again with 55. Your guess is too high. And obviously I've just used for consistency 21, 35, and 55, but this will work with any numbers below, greater than, or equal to the number that we're guessing. And one last thing we can look at is, in this case, if it's not equal to this, so it'll skip this, so if they don't guess correctly and they don't guess, and their guess is not too low, then we know that their guess has to be too high, because if it's not equal to the correct number and it's not less than the correct number, then it must be greater than the correct number. So in a sense, this is kind of extra. So what we can do is just go ahead and delete the check, and instead of this being an else if, make it an else. So that way it'll catch the, if it's not equal and it's not less than, then it has to be too high. So you don't even need to check if it's too high, because you already know that it must be too high if it ever made it to this point. And then just to show that it works the same, do 35. You guessed correctly. Run it again, 21, you guessed too low. And lastly, 55, you guessed too high. So as you can see, nothing changed between the implementation with two else ifs and the else. And that's just because the else is like the catch-all, and since we only have 3 possible values that we could have, it works exactly the same. And so in this code, we were able to see if, else, if, and else. And you also got exposure to comparison operators, or logical operators is what they sometimes call them. So equals equals checks if the value is equal to one another. Less than checks if it's less. And then I erased it now, but greater than checks if it's greater, as expected. The other one that's commonly used, there's a few operators that there are, but I'm not going to actually run it. But if you do this, not equals, so the exclamation mark in our code is not. That's just what they chose, not exactly sure why. Different languages have different things, like Python actually you write not. But in C++, and I believe Java is exactly the same, if I remember correctly, you use the exclamation mark to say not equal. So you can say something like correct num does not equal guess. And so if this line right here was inside of like an if statement for checking a condition, it'll check if it's not equal to the guess. So it's kind of the opposite of the first line that's inside the if. So if we change this to not equals, it'll give us the exact opposite. So if they equal 35, it'll be false and skip it. But if they enter anything besides 35, so if you enter 21 or 55 or any other number, this will evaluate to true, which means that part will be executed. So I'm not actually going to run it, but to show it a little clearer, if you change this to not equal to guess, this code won't make any sense because it'll never get to these conditions. Or actually it will. The else would now become the one where it's equal to the guess. But in any sense, it doesn't really make sense to do it this way. But now, if anything besides the guess is entered, it'll evaluate to true inside here and execute whatever is here. So in our case, it would make more sense to make this say incorrectly. Yeah, so now if anything's entered, this will be, anything besides 35 is entered, this if statement will be executed and it'll say you guessed incorrectly. So I'm not going to run this because it doesn't make a ton of sense to use it, but just let to know that there is that other option that you can use for checking. And there's a few others, but those are the most commonly used. And you can pretty much get by with equal to, not equal to, greater than or less than. You can almost always get by. And as you saw, you can usually get by even without the not equal because you can do less than, greater than. But for things like comparing strings or other stuff like that, you might want to use the not equal to just say, oh, these two are not equal to each other. Okay? So I hope this was a good little introduction to if, else if, and else statements and the general term of branching. If you have any comments about the code that I did or any questions to follow up, go ahead and post it in the comments. If you like this video and it's helpful, go and hit like and then subscribe because there'll be more videos to come.